Continuously compounding interest is one of the more interesting examples of calculus being used in the real world. It's all about your money turning into more money. Who doesn't like that? So, what if you want to figure out how long it's going to take for your investment to turn into a certain amount with a given interest rate? Well, that's exactly what we're going to be doing today. Jake here, coming at you with another math problem. Today I'm going to be showing you how to solve for time in the continuously compounded interest formula. So let's just jump right into it. So here's the problem we're going to be going over today. If $3,000 is invested at 7% interest compounded continuously, how long will it take for the investment to be worth $4,500? And I've already gone ahead and jotted down the continuously compounded interest formula, which is one of the formulas on my integral calculus cheat sheet I came out with recently. If you want to learn more about that or go grab yourself a copy right now, there's a link down in the description where you can grab that. So click over there, grab that, come back, and I'll show you how to use this formula. So let's go ahead and start off by breaking down this formula piece by piece. This is going to give you a formula which tells you the value of an investment at some time t. Our a sub 0 is going to be your initial value of the investment. So in this case, we're investing $3,000. That tells you right off the bat our a sub 0 is going to be 3,000. E is a known constant. It's kind of like pi. It's always just going to be left as e. The r is going to be your interest rate, your annual interest rate. And what we need to do is take our 7% interest and convert that from a percentage to a decimal. Well, to do that, we just move the decimal place over 2 spots. So moving that over 2 spots will just give us 0.07. And then the t is just going to remain as t. And what we want to do basically is we're trying to figure out how much time will have to pass in order for this investment to be worth $4,500. So if we set this whole thing equal to 4,500, then we can go ahead and solve for t. So I wanted to show you an example of how to solve for time in the continuously compounded interest formula. So what we want to do at this point is move the rest of this stuff away and get the t all by itself. So first of all, we'll want to divide both sides by 3,000. And then, since the thing we're trying to solve for is stuck in the exponent here, to get it out of the exponent, what we can do is take the natural log of both sides. And what that does is it cancels out the e and basically cancels out the base of the exponent and just leaves us with whatever was the exponent. Now we can just divide the 0.07 over. So we know then t equals natural log of 1.5 over 0.07, but we do want to actually figure out what that is in years, get an actual number for that. So we can plug that into a calculator, and that tells us that t is going to be about 5.79 years. If it's making a little more sense to you now, please go ahead and hit that like button, and don't let YouTube decide which problems you get to learn how to do. Go ahead and hit that subscribe button and the bell icon as well so you make sure to catch all my videos. And I'll help you get your grades up all term long. If you want to see some more exponential growth indicator problems, go ahead and click over there on the left side of your screen. Thanks and see you next time.